All right, buckle up, everybody, because
Oh,
we are diving headfirst into the sometimes exhilarating, sometimes terrifying world of scalability.
it can definitely be a bit of a roller coaster ride, that's for sure.
But don't worry, we are here to guide you through it with not one, not two, but 10.
10.
Yes, 10 battle-tested tips for achieving scalability nirvana.
Sounds ambitious.
Oh, it is. But trust me, after this deep dive, you'll be scaling systems like a seasoned pro.
All right, I'm all ears. Let's hear those tips.
Okay, tip number one, and this is a big one.
Yeah.
Simplify, simplify, simplify.
The KISS principle. Keep it simple, stupid.
Exactly. We've all been there, right?
Yeah.
Staring at a tangled mess of code that looks like it was written by a caffeinated octopus.
Oh, yeah. Trying to decipher someone else's spaghetti code. That's always fun.
It's not fun at all. But seriously, keeping your code clean and your design elegant is absolutely crucial for scalability.
I couldn't agree more. It's like building a house. You need a strong, simple foundation before you start adding all the fancy bells and whistles.
So what are some practical ways to achieve this elusive simplicity?
Well, one approach is to embrace the beauty of microservices.
Microservices, huh? That sounds kind of buzzwordy.
It might sound buzzwordy, but trust me, it's a game changer. Think of it like breaking down a monolithic monster of an application into smaller, more manageable chunks.
Okay, so instead of having one giant, unwieldy beast of an application, we break it down into smaller, more specialized units.
Right. Each microservice handles a specific function, making your code base easier to understand, test, and scale.
And if one microservice goes down,
It doesn't bring the whole system crashing down.
I
Exactly.
like the sound of that. It's like having a team of specialized ninjas, each handling their own mission.
Way more effective than one overwhelmed superhero trying to do everything at once.
So how do we go about actually breaking down a monolithic application into these microservices? It sounds kind of daunting.
Start by identifying clear boundaries within your application. Think about the different functionalities and how they can be separated into independent units. Then gradually peel off those layers.
Gradually peel off those layers.
Yeah, creating separate microservices for each one.
Gotcha.
But remember, communication between those microservices is key.
Oh, right. They can't just be operating in silos.
Exactly. So you need a robust and scalable communication layer in place.
Like a well-oiled machine, where each part knows its role and communicates seamlessly with the others.
I like that. A well-oiled machine.
Okay, tip number 2 is about data replication.
Data replication.
Yeah, basically making copies of your data.
Oh, so like backups.
Well, sort of, but it's more than just backups. It's about creating multiple read-only copies of your database to distribute the load and prevent your servers from getting overwhelmed.
So instead of having all your users hitting the same database at the same time, you spread them out across multiple copies.
Exactly.
That makes sense.
But hold on, wouldn't that just create a whole bunch of storage headaches?
It can, but there are ways to mitigate those headaches. You can choose storage systems that are designed for replication.
Oh, okay, so there are systems that handle this kind of thing automatically.
Right. They handle data consistency and all that jazz. And the performance gains you get from data replication are often worth the extra storage costs.
I mean, a little extra storage is a small price to pay for a smooth-running system.
You got that right.
Yeah.
You don't want to be the one responsible for that server meltdown.
Nobody wants to be that guy.
Or gal. Don't forget the gals.
Okay, moving on to tip number 3. Splitting data.
Splitting data.
Yeah, like imagine you're running an e-commerce platform that sells everything under the sun. It wouldn't make sense to store all that data in one massive, unwieldy database.
That would be a nightmare to manage.
Total nightmare. So how do we go about splitting it up effectively?
One approach is to split your database based on business domains.
Business domains.
Like, you could have one database for customer information, another for product information, and another for orders.
I see. So instead of having this giant blob of data, we create smaller, more focused databases that are easier to manage and scale.
Exactly.
But what if one database gets way more traffic than the others? Wouldn't that create a bottleneck?
Excellent question. And that brings us to tip number 4. Splitting data strategically.
Strategically.
We need to ensure that our data is distributed evenly across multiple databases to prevent any one database from getting overloaded.
So we don't want all the high-maintenance data lumped together, causing a digital traffic jam.
Nope, we don't want that. One powerful technique is called sharding.
Sharding. Now, that sounds like a term I've heard thrown around in the database world.
It's a fancy way of saying dividing your data into smaller chunks and distributing those chunks across multiple servers.
So like slicing up a pizza and giving each slice to a different delivery person.
Exact.
But how do we choose the right criteria for sharding?
Choosing the right sharding key is crucial. You need to consider factors like data access patterns and anticipated growth.
So it's all about finding the right balance between data separation and efficient access. Got it.
You're getting it.
Now let's move on to tip number 5. Data center redundancy.
Ah, redundancy. The key to surviving unexpected disaster.
Exactly. Let's say there's a power outage or a natural disaster that takes down your primary data center.
Without redundancy, you're toast.
So how do we build this fortress of data center redundancy?
It starts with having multiple data centers strategically located in different geographical regions.
So if one data center goes down, you can just switch over to another one. Seamlessly, hopefully.
That's the idea.
But isn't that like super expensive, running multiple data centers?
It does come with costs, but it's about weighing those costs against the potential risks. You can explore different redundancy models.
Different mumbles.
Yeah, you could have an active-passive setup where one data center is live and the other one is on standby.
Like a backup quarterback, ready to step in if the starter gets injured.
Exactly. Or you could have an active setup where both data centers are actively handling traffic.
So it's all about choosing the strategy that best aligns with your budget and risk tolerance. Makes sense. Okay, before we move on, I have to confess something.
Confession. Ooh, this is getting juicy.
Not that kind of confession.
Yes.
The world of storage options just completely overwhelms me. There are so many choices. It's like trying to pick a flavor of ice cream at a shop with a million different flavors.
I feel you. There's file storage, NoSQL databases, wide column stores, relational databases. It's a lot to take in.
So how do we even begin to navigate this storage jungle?
Well, the first step is to understand the different types of storage and their strengths and weaknesses.
Okay, so like, what's the deal with file stores? I know it's good for storing unstructured data like images and videos.
Right, but it doesn't offer the same level of data consistency and transaction support as a database.
What about databases? I've heard of relational databases like MySQL and PostgreSQL, but then there are all these NoSQL databases popping up everywhere.
Ah, yes. NoSQL databases. They're all the rage these days.
So what's the difference between a NoSQL database and a relational database?
Relational databases are great for structured data, data that fits neatly into rows and columns. NoSQL databases are more flexible. They can handle unstructured or semi-structured data, and they're often better suited for high-traffic loads.
So it's like choosing the right tool for the job.
Exactly.
But how do we know which tool is the right one for our specific needs?
You need to carefully consider the type of data you're dealing with, your performance requirements, and your scalability goals. Some storage solutions, like Cassandra, even come with built-in features for sharding and replication.
That's super helpful. So it's all about understanding our data, our needs, and our goals, and then picking the storage solution that aligns with all of those things.
You got it.
Okay, on to the next tip. What is it? Number 7.
Yep, number 7.
And it's all about consistency.
Consistency.
Yeah, like making sure that our data is accurate.
Oh, that's super important, especially in a distributed system.
So is there like a trade-off between consistency and performance?
There can be. In some NoSQL systems, for example, if you need to guarantee strong consistency, you might need to contact multiple nodes.
Multiple nodes.
Yeah, like multiple servers to make sure everyone has the same data. And that can take time and impact performance.
So it's like checking multiple sources to make sure a piece of information is accurate. The more sources you check, the more confident you are, but it takes longer.
That's a great way to put it.
So how do we strike that right balance between consistency and performance?
It all depends on your application. Some applications need rock-solid consistency, things like financial transactions, but others might be able to tolerate some temporary inconsistencies.
So, like with a social media feed, it's not the end of the world if someone sees a post out of order for a few seconds.
Exactly. It all comes down to understanding your requirements and choosing the right consistency model.
Got it. All right, moving on to tip number 8. And this one is all about security. Firewalls.
Firewalls. Don't get me started on firewalls. I mean, they're important, but they can also be a real pain in the...
I'm a bit of a security freak myself. But I also know that you can overdo it with security.
Yeah, for sure. You don't want to turn your system into an impenetrable fortress.
Right, because then it just becomes too difficult to manage and too slow for users.
Exactly.
So how do we strike that right balance between security and performance?
Well, one key principle is to keep your firewall rules as simple and clear as possible.
Simple and clear, I like that.
Avoid unnecessary complexity, and regularly review your firewall configuration.
Keep those firewall rules lean and mean.
You got it.
All right, tip number 9, challenges a common assumption about transactions.
Transactions, what about them?
The assumption is that they're always necessary. But, sometimes there are alternative approaches that can achieve the same outcome without all the overhead of a full-blown transaction.
Like what?
Well, one interesting concept is event sourcing.
Event sourcing.
Yeah, it's kind of like keeping a detailed log of every change that happens to your data.
Instead of just storing the final result.
Exactly.
Ah, that's interesting.
It can be a bit mind-bending, but it can also offer more flexibility and scalability in certain situations.
Well, I'll have to look into that.
All right, last tip. Tip number 10, write and trust. This one's for all my fellow control freaks out there.
Oh boy, I'm guilty of this one too.
The ones who double-check everything. Send a text message, that immediately check to make sure it's sent.
Yep, that's me.
Well, in the software world, that kind of behavior can be a real performance killer.
How so?
Well, once you've written data to disk, to the cache, to the database, trust that it's there.
Trust.
You don't need to read it back every single time to validate it.
Oh, okay. So it's about eliminating those unnecessary read operations.
Exactly.
I can see how that would improve performance.
So let go of that control, embrace the trust, and watch your system soar.
Soar.
All right, we've covered a lot of ground in this first part of our scalability deep dive, from simplifying our code to trusting our systems.
It's been quite a journey.
And we're just getting started. In the next part of our deep dive, we'll explore even more advanced techniques. So stay tuned, folks, because the scalability adventure continues.
Can't wait. So, sometimes we get so caught up in doing things a certain way, the way we've always done them, that we kind of forget to step back and ask ourselves, is there a better way to do this?
Right, like if it ain't broke, don't fix it. But also, maybe it is kind of broken and we just haven't noticed yet.
Yeah, exactly. We need to be open to new approaches, new ideas. Technology's always evolving.
It's like you can't just keep using the same tools and techniques forever and expect to keep up.
Right. You got to stay sharp. You got to stay current. But one thing I've noticed, one of the biggest traps that developers fall into,
Uh-oh, what's that?
it's this urge to optimize everything prematurely.
Oh, tell me about it. I've spent countless hours tweaking and fine-tuning code, trying to squeeze out every last bit of performance.
Yeah, and sometimes those micro optimizations just don't make a difference in the grand scheme of things.
It's like you're so focused on the details that you lose sight of the big picture.
Exactly. And the funny thing is that premature optimization can actually make your system less scalable in the long run.
Really? How so?
Because it adds complexity to your code, makes it harder to understand and maintain.
And that can lead to more problems down the road.
Right, so what's the solution? Focus on the big picture first. Get your architecture right, choose the right technologies.
Lay that solid foundation.
Exactly. And then once you have that, you can start thinking about optimization. But even then, it should be driven by data, not just your gut feeling.
Data-driven optimization. I like that. So how do we gather this data? What tools can we use?
Well, profiling is your best friend here. It's like putting your code under a microscope.
So we can see exactly what's slowing things down.
Yeah, there are lots of great profiling tools out there. You can find them for specific languages or for, more general system-level analysis.
Okay, so profiling helps us find the bottlenecks. But what if we've optimized everything we can and our system's still struggling? What do we do then?
Well, sometimes you got to throw more hardware at the problem, more servers, more memory, but that's not always the best solution.
Right, it can get expensive.
Yeah, and sometimes you just hit the limits of what your current architecture can handle. So then, you have to think about some bigger changes like re-architecting your system or maybe adopting some new technologies.
Re-architecting your system, that sounds intense.
It can be a big undertaking, but sometimes it's necessary. Like if your system is constantly crashing or you're spending more time fixing bugs than building new features, it might be time for a major overhaul.
Okay, so let's say we've reached that point. We know we need to re-architect. Where do we even begin?
Well, start with a clear vision. What are your goals? What are your pain points? What move functionalities do you need? Once you have that figured out, you can start exploring different architectural patterns and technologies.
Right. But there's so many options out there. How do we know which ones are right for us?
That's the million-dollar question, isn't it? There's always something new and shiny coming out, promising to be the next big thing, but you gotta be careful.
Don't get caught up in the hype cycle.
Yeah, focus on the fundamentals. Choose technologies that have a proven track record. And don't be afraid to stick with what you know if it's working well for you.
Right. If it ain't broke, don't fix it. But it's also important to stay informed.
Oh, absolutely. Keep learning, keep experimenting, but be selective. Don't just jump on every bandwagon that comes along.
So balance is key. Stay informed, but don't get swept away. Are there any resources or communities that you recommend for developers who want to, keep up with the latest trends in scalability?
Oh, yeah, for sure. Conferences are always a great way to learn and network. There are some really great ones out there focused on scalability and distributed systems. And there are also tons of online communities, forums and blogs and Slack groups where you can connect with other developers and kind of, share knowledge and get support.
That's awesome. It's like having this huge network of experts at your fingertips. But, sometimes you just want to curl up with a good book and really dive deep into a topic.
Oh, yeah, I love a good technical book. Actually, there's one that I always recommend to people who are getting started with scalability. It's called Designing Data-Intensive Applications.
Designing data-intensive applications. Okay, I'm writing it down. Who wrote it?
It's by Martin Klipman. It's a fantastic book. Really goes deep into distributed systems, data storage, all that good stuff.
Sounds like a must-read. But reading about it is one thing. Actually putting it into practice is another. What are some practical tips for developers who are just, starting their scalability journey?
Well, my number one piece of advice would be to start small and iterate. Don't try to build the perfect system right out of the gate.
Yeah, that's a recipe for overwhelm.
It is. Start with a simple, manageable piece of your application.
Kind of like a minimum viable product.
Yeah, exactly. And then as you gain experience and learn more, you can gradually expand and improve your system over time.
Okay, so start small, iterate, learn as you go. But what about when you hit a roadblock? You just can't figure something out. Are there any resources or communities that you recommend for developers who are feeling stuck?
Oh, definitely. There's this amazing community of developers out there who are passionate about scalability, and they're super helpful. Conferences are great for networking, but don't underestimate the power of online communities. There are forums, blogs, Slack groups where you can connect with people who've been there, who face the same challenges.
That's so valuable
Yeah.
to be able to tap into that collective knowledge and experience. But let's say we're feeling adventurous. We want to explore the cutting edge of scalability. What are some emerging trends that we should be keeping an eye on?
Ooh, that's a good question. One trend that's been getting a lot of attention lately is serverless computing.
Serverless. I've heard that term thrown around, but I'm not entirely sure what it means.
It's basically a way of running your applications without having to manage servers yourself. You let the cloud provider handle all the infrastructure stuff,
So you just write your code and deploy it, and the cloud takes care of the rest.
pretty much. And the cool thing is, serverless platforms are designed to scale automatically.
Automatic.
Yep. So if you get a sudden spike in traffic, the platform will spin up more resources to handle the load.
Sounds pretty amazing. But are there any downsides to serverless?
Well, it's not a perfect solution for every situation.
Yeah.
Sometimes you might need more control over your infrastructure, or you might have security concerns about running sensitive data in the cloud.
Right. It's all about choosing the right tools for the job, weighing the pros and cons.
Exactly. But overall, I think serverless has a lot of potential. It can really simplify things for developers and make it easier to build scalable applications.
That's awesome. So serverless is definitely one to watch. Anything else on the horizon that's got you excited?
Well, the field of scalability is always evolving. There's always something new and exciting just around the corner. But the fundamentals, they always seem to stay the same.
Yeah, the fundamentals like solid code design, efficient algorithms, understanding your data.
Those things never go out of style. So it's good to have a strong grasp of the basics before you start chasing all the shiny new toys.
Yeah, don't get me wrong. It's good to be aware of new trends. But you don't have to jump on every bandwagon that comes along.
Yeah.
Especially if you're already working with something that's stable and reliable and meeting your needs.
Right. If it ain't broke, don't fix it. But, there are times when you might need to consider adopting new technologies. Maybe your system's just not scaling the way you need it to.
Or maybe you're facing some new challenges that your current technology stack just can't handle.
Yeah, exactly. Like, If you're constantly hitting performance bottlenecks or you're finding it really difficult to add new features without breaking things, maybe it's time to start looking at some different approaches.
So how do you know when it's time to, actually make that leap to a new technology?
Well, it's a judgment call, right? There's no easy answer, but I think
Okay.
a good rule of thumb is to ask yourself if the benefits of switching outweigh the costs. How much time and effort is it going to take to migrate to the new technology? What are the potential risks? And are those risks worth taking given the potential rewards?
Right. Like, is this new technology actually going to solve my problems, or is it just going to create a whole bunch of new ones? Because, sometimes the devil you know is better than the devil you don't.
Yeah, I think it's all about finding the right balance between being cautious and being open to new possibilities, right? You don't want to be so stuck in your ways that you miss out on opportunities to improve, but you also don't want to jump ship every time a shiny new technology comes along.
So you got to do your research, weigh the pros and cons, and then make an informed decision.
Exactly. And sometimes the best way to learn is to just roll up your sleeves and experiment, get your hands dirty with some of these new technologies, build a proof of concept, see how it works in practice.
I love that idea. Build a proof of concept, a small scale experiment to test out the new technology before you go all in.
Right, because sometimes, the theory and the reality don't always match up.
Yeah, it's one thing to read about a new technology, but it's another thing entirely to actually implement it and see how it behaves in the real world.
Exactly. So I would encourage folks to be curious, to experiment. Don't be afraid to try new things, but do it in a controlled way so you can learn from your mistakes and make informed decisions about whether a particular technology is a good fit for your needs.
Awesome. Well, I think that about wraps up our deep dive into scalability.
Yeah, I think we covered a lot of ground today, from the basics of simplifying code and choosing the right storage solutions to the challenges of managing data consistency and security. And then, we even touched on some of the emerging trends like serverless computing and the importance of staying curious and experimenting with new technologies.
It's been an amazing conversation, so much great information and insights.
Yeah, I had a lot of fun.
I hope our listeners are feeling energized and equipped to tackle their own scalability
Oh,
challenges.
you too. I hope so.
And remember, folks, scalability is a journey, not a destination.
That's a good one. A journey, not a destination.
So keep learning, keep experimenting, and most importantly, keep building awesome things.
Absolutely. Build awesome things.
Until next time, happy scaling.